dealing with is we're dealing with questions that basically have letters, mainly letters instead of numbers. Okay. So the first thing we're going to do is we're going to read question 6, and we're going to try and take apart the language to see what we can do here. A car moves with acceleration 3a and a deceleration 5a. So it can do this. Can being the key word there. Find in terms of k the time taken to cover a distance of 98k squared from rest to rest, subject to speed limit of 15 and question 2, subject to no speed limit. Let's concentrate on question 1. In question 1, usually when we have a deceleration and acceleration, what happens is we're going to accelerate. We're going to hit our speed limit of 15 isn't that correct? And then we're going to keep going as long as we can. And then we're going to jam on the brakes. And then we're going to have two triangles and a rectangle. What we know is the total distance is, what's the distance? 98k squared. Okay? And that's all the information I need for the first part, right? Everything I needed from the question is now got, okay? No. Okay, there we go. Okay, so let's do this, okay? Now, 15 distance of 98, and what's the acceleration, deceleration? Acceleration is 3a, deceleration is 5a, okay? So, we need to find the total times, isn't that correct? So there's going to be three things. There's going to be T, T1, T2, and T3. Okay. Now, what we need to figure out is, remember what I told you about, so we're going to UVAS, we can UVAS both systems or we can use TAN. So I'm just going to UVAS, I'm going to UVAS the acceleration and deceleration zone. Okay. So the acceleration and deceleration. Okay, so what we get here is the following. U is, it's starting off from rest. It's velocity, we find velocity we don't know. It's acceleration. Sorry? But it starts off from rest. Okay. V is 15 Take out your book and do examples from chapter 1 on exercise you already done. Okay. So what we say that's 15 the acceleration is 3a, yeah? S we don't know, T we don't know. So what we can use is V equals U plus A T. We can say that 15 ends up to be 0 plus AT, which is going to be 3AT. And then we know T for the first section has got to be, what's 15 divided by 3A? 5k. So the first one takes 5k seconds. Okay? The second one, U is 15 This is where you're up here, you're starting here, and you're starting to decelerate downwards. Okay? The first one was you're starting the blue. This is the blue. And the second part is the red. Okay? Now, for the red part, we know that the final velocity's got to be 0. Acceleration minus 5a. S, and we know S? No idea what S is. So let's use V equals U plus AT again and see what we get. Okay, so V equals 0, U equals 15 AT is minus 5AT. Bring the 5AT over to the other side and then divide by 5A. T is going to be equal to 3k. Okay, so we now got 3k and 5k respectively. We've used up information set for the acceleration and the deceleration. What's the only information or question that we haven't used up yet? We haven't. Speed is not constant because you're accelerating. Constant velocity then down. So I'd argue we haven't used the total distance yet. Okay. So does anybody remember the total distance? It's the area underneath the graph, isn't it? Yeah. So it's basically triangle plus rectangle plus other triangle, and that's all going to be equal to, what's the distance? 98k squared. We still know that the distance at constant velocity is t2. The distance under acceleration is 3k. Deceleration. The time under acceleration is 5k. And we know the height of each triangle to be 15 ak. Isn't that correct? And this one here is 15 ak. So what we got to do next is we got to find the area of each one. So it's going to be a half base by height, 5k times 15 ak, plus the area of a rectangle, which is just going to be 15 ak times t2, and then the area of the last one is going to be a half 3k times 15 ak, and that all equals 98k squared. Okay, so I'm just not going to be able to fit that in for a minute. Just take out the calculators, just do a quick job on the numbers there. So 75 divided by 2, 37.5 ak squared, plus 3 times 15, divide that by 2, that's going to be 22.5 ak squared. That's the last one. And we still have our 15 ak t2, and that equals 90 ak squared. So the next part's really easy. Just add the first two together, bring them over to your side, and take them away from 90. It's 60, is it? Yeah. 60 ak squared from 90 ak squared gives you 30 ak squared. And now all of a sudden we divide 30 by 15 ak, and then t2 is going to be equal to just k. Alright, and this brings the total time to 2k, excuse me, 2k. So the total time is going to be, t1 was 5k, t2 was 2k, and t3 was 3k, and all that together gets you 10k. So 10k is the total time when we have no speed limit. Is that okay? Grant. That's the answer when you have a speed limit of 15 ak. In the next question we will have no speed limit. The next question is when you have no speed limit, okay? And when you have no speed limit, in the last question we had like a plateau on top. Well, when you have no speed limit, it's more like a peak of a mountain. Just go straight up and straight back down again, okay? Now, first of all, we got to write down our acceleration and deceleration again, which are 3a and minus 5a. Now, this diagram here is actually inaccurate. And the reason why it's inaccurate is if your deceleration is stronger or faster in magnitude than your acceleration, it means your ascent is going to be shallower than your descent. Okay? So just keep that in mind. Okay? What we know about, currently speaking, what we know about, we can UVAS both systems. If you wish, when you UVAS both systems, we're told U is U. 0, yeah. V is V. A is 3A. S is S. Don't know. T, we don't know. So this is the acceleration, which would be the red part. And now for the blue part, which is deceleration. So blue being deceleration. And what we can do here is we know that U equals V. V equals 0. A equals minus 5A. S equals we don't know what. And T equals we don't know what. Okay. So what we're looking to work off is phi equals U plus A T. And what I recommend is we try and get we either try and get A on its own, or we try and get phi on its own. Phi is the only thing that's in common to both of them, isn't it? Okay. For these type of questions, okay, because there's no intermediate points, what you should do is you should make up a total time t, okay? And t is going to be divided up into t1 and t2, okay? Now, what you have to realize about t1 and t2 is there's a ratio of t1 to t2. Oh, sorry, small t1 to small t2. There's a ratio, okay? And as I said, the ratio is directly in proportion to their actual acceleration and deceleration, okay? So, because 5a is the bigger acceleration, magnitude of acceleration, t2 is going to be a smaller number than t1. You happy with that? So therefore, t1 is going to be roughly 5, because it was 5a to 3a, wasn't it? So you do is you spin them around, because it's in that ratio that t2 is longer than t1. Okay? Then you get rid of the a's, and you have a ratio of 5 is to 3, and that gives you 5/8 and 3/8. Okay? It's the same thing, isn't it? So this means that T1 is 5/8 of t, and T2 is 3/8 of t of total time. Okay? Now with this information, we now have a common link with time. Time is now under the same variable, big T. Okay, everybody got that? Now, let's try phi equals U plus AT, because we'd like to find out what V is in terms of the variables, okay, A and T. So, for the first one, we're going to use phi equals U plus AT. Can anybody tell me, although you're following me here, why did I go? What we're going to do next is we're going to try and turn V into we're going to try and change V and get in terms of A and T, A and big T. Okay. So what phi here is going to be is phi equals U plus AT, which is going to be 0, plus 3A. 3AT, so it's AT, and AT is going to be 15 AT divided by 8. Okay? And if we were to use this set of information, we'd actually get the same answer, wouldn't we? Phi has a common value, does it not? You reach your maximum velocity, V, and that's it. So it doesn't matter which information set we use, we're still going to get 15 AT. So now that we know that this is 15 AT divided by 8, we now know that our maximum height, our height of each triangle, is 15 AT divided by 8. What do we know about the base of each triangle? The first one is 5/8 T. The second one is 3/8 T. And what we're going to get is we're going to multiply them out. So it's going to be a half So that happens on occasion. So it's going to be a half 15 AT, a half base by height, so sorry, 5 over AT times, and this is capital T by the way, this is going to be 15 AT divided by 8 plus a half 3 over AT multiply by 15 AT over 8. Okay, so let's just multiply that out first. 5 multiplied by 15 divided by 128, because 8 by 8 is 64, 64 by 2 is 128. So the first one's going to be 15 over 64 AT squared. The best thing just to do is to ignore the letters and just put the rest of it into your calculator. The second part is going to be once again all over 128. Sorry, all over 128. So it's going to be 3 multiplied by 15, which is 45. 45 divided by 128 is still 45 over 128. Yes. Sorry, the first one's 75 over 128. Yeah. Is that correct? Yeah, sorry. So when you put the first one into your calculator, it's actually 75 over 128. Just double check all your calculations before you move on, just so you don't cost yourself a mistake later on. So 45 over 128 AT squared. We're going to add the two of these together, and we should get 75 plus 45 gives me 120. 120 divided by 128 is 15 over 16 AT squared, and we know that this is equals 90 AK squared. The A's will cancel. Multiply 90 by 16. Divide your answer by 15, and what you get is T squared ends up to be 96 K squared. Therefore T must be equal to the square root of 96, which is 4 root 6 K. Another faster way of doing this would have been, instead of using two triangles, would have been to use one big triangle. Okay, and the one big triangle would be of base T. It'd be of height 15. What's the 15 over 8 T? Is it 15 over 8 AT? Sorry. Yeah, and then you'd use half base by height, which would be 15 times T times 15 over 8 AT. And then this would have given you the 15 over 16 AT squared a lot quicker than two triangles. So be in a test, it's good. That'd be better technique, especially for saving yourself time. Okay, well done.